good morning to one and all present here. See, today we are going to see about some solved examples for KNN algorithm, which is one of the most popular algorithms in your machine learning model. See, let us see how this KNN is applied for the given data set. Like the problem statement, whatever is given here is you are presented with some data points, let them represented with two features, let it be x1 comma x2, so that they may either belongs to the class A or class B as per your data set instruction. And what we are supposed to do now is, I am supposed to apply k is equal to 3 for the data point 2.5 comma 2.5. So let us see what is given in the question first. They have presented two features. The two features are named as x1 and x2. x1 is having certain values like 1, 2, 3, 3 and 4. Your x2 is having some certain values like 2, 3, 3, 1 and 2. So what is my x1 comma x2 now? That is something like 1 comma 2, or it may be 2 comma 3, or it is 3 comma 3, like that. And the class information what is presented here is, I am having two classes here, let it be class A and class B. Now what is my requirement is, I am supposed to tell whether this feature of 2.5 in x1 and 2.5 in x2 either belongs to class A or class B. That we have to find out with the help of which algorithm? They have mentioned it as, we are supposed to use an algorithm called KNN here. That is K nearest neighbor algorithm. As I have told you earlier, it is one of the most popular algorithms in machine learning model. See, what is my first step is, I am supposed to calculate the Euclidean distance between the points. So this is the formula for finding the Euclidean distance between the data points. Let the distance be represented as square root of x1 minus x2 the whole square plus y1 minus y2 the whole square, which is a pretty known formula to everyone for finding the distance between the two data points. So what we are supposed to calculate? I am supposed to calculate what is the distance of this new point, that is 2 comma 5 comma 2 comma 5 with all other data points. That we will see in a step-by-step manner now. See, the new data point given in the question is nothing but 2.5 comma 2.5. See, now I am supposed to find out the distance between this new point and 1 comma 2. So what is my x1 here? That is 2.5, and what is my x2? That is 1. My y1 is 2.5 again, my y2 is 2. Now I have to apply this with the help of the Euclidean distance formula, whatever we have seen before, with the help of square root of x1 minus x2 the whole square plus y1 minus y2 the whole square. See, I am supposed to find out the numerical values of all these things. So how many data points actually we have? As I referred with my question, I am having 5 existing points given over there. My first point is 1 comma 2, second point is 2 comma 3, third one is 3 comma 3, fourth one is 3 comma 1, and my fifth one is 4 comma 2. So all these represents the values for x2 comma y2. And what is my x1 comma y1? That is nothing but whatever is given in the question again. It is 2.5 comma 2.5. The action of finding the Euclidean distance between all these 5 data points with the new point is presented in this slide. See, these are the final values which are closely approximated. That is 1.58, 0.71, 0.71, and the remaining two are 1.58 as per the calculation. See, what is given in my step 2 is, I am supposed to find out the k nearest neighbors here. Since my k value is equal to 3, what I have to do is, I have to choose the first 3 closest points. So as per my previous step, the 3 closest points are like this. That is 0.71, 0.71 and 1.5. Now the corresponding data points, whatever presented in my data set, that is 2, 3, 3, 3, 1, 2 belongs to which classes? This is also present in the question as the information of A, B and A. See, now I have to go for the majority voting based on those 3 closest neighbors, whichever is voted for many times, so that I may conclude my new data point belongs to such a class. So from this slide, what I can able to see, what is repeated for more number of times, that is class A. So class A is done for how many votes? 2 votes. From which data points? 2, 3 and 1, 2. Class B have done with how many votes? Only 1 vote, that is from the data point 3, 3. So this is the point where I can conclude that majority of the vote belongs to class A. So definitely my new point, that is 2.5, 2.5 is classified as class A. Okay. So that is what your KNN is done with. That is, I can able to find out the new data points belongs to which class based on the given information. So let us see one more example based on this. Like here I have to predict something with the help of KNN regression. See, the problem statement given here is data set of house prices. All my values are represented in meter square. I am supposed to use the K value as 2 as per my question to predict what will be the price of a house with 2500 meter square. See, house size is presented in the question. Actually 5 values of house size is given in the question, and the corresponding price is also given. The units are given here as $1,000. So what is our first step? We are supposed to calculate the Euclidean distance. So you are supposed to calculate the Euclidean distance from 2500 to all the other sizes. So I have done with that thing, that is 2500 minus 1500. For my second data point it is 2500 minus 1700. For my third data point it is 2500 minus 2100. So this is what I have to repeat for all the data points given in the question. So I may get some new values here. Now tell me, what is the K value given in our question? It is nothing but K is equal to 2. Right? So since my K is equal to 2, how many data points we are supposed to select? 2 closest neighbors we are supposed to select. So the house size and the 2 closest values we are supposed to select, and their distance also. Now I have to take the mean of K neighbors. That is, for regression we are supposed to calculate the average price. That is, predicted price is 250 plus 3302 and my predicted thing for my second point is 290. So the estimated price for 2500 meter square house is nothing but $290,000. So this is how we can able to predict the value of something with the help of a KNN regression. So apart from your KNN, you are having one more important algorithm in your machine learning, that is for called as K-means algorithm. The purpose of this K-means algorithm is for clustering. The purpose of your KNN algorithm is for either classification or it can be used for prediction. The first solved example we have seen is for classification. The second example based on your house price we have seen it for prediction. So this is another one algorithm available in your machine learning model. So the primary purpose of this algorithm is you can able to cluster the data points like this. See, whatever is represented in green color may be cluster 1, and whatever is given here as cluster 2, and this is your cluster 3. Like that you may go up to n number of clusters, and whatever is marked with this red color X is called as the centroid. So here are some steps we have to apply for K-means algorithm. First of all, you have to randomly initialize the K points. Okay. Then you are supposed to categorize each item into that closest point. Like whatever you have chosen as a closest point, Now you have to calculate the distance between that point with other points available within that surface, whatever you have considered, maybe with the data set whatever you have considered. We are supposed to repeat this process until the given number of iterations, or some 2 to 3 number of iterations at least has to provide the same result without any change. So at that point you can stop your calculation and you can able to form the points into a cluster. So in this k-means you are having some certain disadvantages. The first thing is random initialization of a k point, because it will provide you different number of iterations with the different results for different users. And the second thing is it leads to outliers. Outliers in the sense it is very sensitive with the help of the noises present in your data set. And predefining the number of clusters already is again some major issue to be considered here, because based on the size of the data set, it is really difficult to predefine the number of clusters, whether they may fit in within 5 clusters or 10 clusters or 50 clusters. That is different over here. And shape and size of the cluster is again a problem. Like one cluster can accommodate more number of data points, the another one may have very sparse number of data points. So that is some limitations of your k-means algorithm. So in order to overcome all these issues, you are having one more variation of your k-means algorithm, which is called as k-means plus plus algorithm. See, what is the major difference between your k-means and the k-means plus plus algorithm is, you are supposed to select the first centroid randomly from the data points. This is the major difference between your k-means and k-means plus plus. Then you have to select the subsequent centroids, which is completely missing in your k-means, so that the remaining process is going to be the same. First you have to choose the first centroid, then you are supposed to choose the subsequent centroids as per your k-means plus plus. So this is the major difference between your k-means and k-means plus plus algorithm. See, the random centroid initialization is very random in k-means, whereas there we are following some strategical methodology. And regarding your cluster quality, this is again random, suboptimal, but this will provide you the better results and size and shapes of the clusters when compared with your k-means. And regarding convergence, your k-means is very slow, whereas your k-means plus plus will be little faster when compared with your k-means. And initialization time, since I am going for a random way, this is very quick and very simple, but this may take some time, since I have to calculate something, what will be my first centroid. And this is regarding the clustering. Since my centroid initialization is random, maybe the cluster division will be poor here, but this will not lead to that thing. And regarding the algorithmic complexity, this is simple and fast, whereas this is little complex when compared with your k-means. K-means plus plus is little complex when compared with your k-means. So with this, let us conclude. So that we have seen 3 algorithms today. One is KNN, another one is k-means, and another one is k-means plus plus. So these are the important contents available in your unit 2. Thank you.